The National Electrical Code, or NEC, does address the possibility of terminating two cables under a single compression lug, particularly concerning the grounded conductor. The NEC does allow for the termination of two cables under one compression lug, given certain conditions. Section 250.12 C, titled Conductors of Different Sizes Under One Terminal, initially states that conductors of different sizes must not be connected within the same terminal or splice unless an identified terminal or splice suitable for the purposes used. However, Section 110.14 C provides an exception to this general rule. The exception states that conductors of different sizes shall be permitted to terminate under a single connector if the device is identified for such use and is rated for the ampacity of the largest conductor connected to it. This exception is critical. It means that if the compression lug is specifically identified for such use, meaning it is designed and tested to accommodate multiple conductors, and if it is rated for the ampacity of the largest conductor connected to it, then terminating two conductors under the single lug is permissible. In a specific scenario, the question mentions two 500 MCM cables being terminated under a 1000 MCM rated compression lug. If the 1000 MCM compression lug is identified for use with multiple conductors and is appropriately rated, this configuration can be compliant with the NEC. However, adherence to the NEC requires meeting other requirements. Firstly, the compression lug must be properly sized for the conductors being terminated. While the lug might be rated for 1000 MCM, ensuring it physically and electrically accommodates two 500 MCM conductors is vital. Secondly, the conductors must be stripped to the proper length and twisted together before being inserted into the lug. This ensures a secure and effective electrical connection. Thirdly, a lug must be properly crimped using the appropriate tool. The correct crimping tool and die are crucial for achieving a reliable and safe connection. If these requirements are not met, the connection may not be safe or reliable. The implications of these requirements are profound. The identification of the lug for multiple conductors means the manufacturer has tested and approved the lug for such applications. This information is typically found in the product documentation or specifications. The ampacity rating ensures that the lug can handle the current carrying capacity of the connected conductors without overheating or failing. The proper sizing of the lug ensures that the conductors fit securely and make good electrical contact. The stripping and twisting of the conductors prepare them for a secure connection within the lug. Proper crimping ensures that the lug is mechanically and electrically sound, providing a reliable connection that can withstand vibration, temperature changes, and other environmental factors. Several key aspects must be considered for a safe and compliant installation. Firstly, the listing and labeling of the compression lug are crucial. The lug must be listed by a recognized testing laboratory, such as Underwriters Laboratories, or UL, and labeled for the specific application of terminating multiple conductors. Secondly, the conductor compatibility is essential. The lug must be compatible with the type of conductor being used, such as copper or aluminum. Different metals require different types of lugs to prevent corrosion and ensure a reliable connection. Thirdly, the proper installation techniques are required. The conductors must be properly cleaned and prepared before insertion into the lug. The lug must be crimped with the correct tool and die, following the manufacturer's instructions. The connection must be inspected to ensure that it is secure and that there are no loose strands of wire. Furthermore, consider the potential for future issues. Over time, connections can loosen due to vibration, thermal expansion and contraction, or corrosion. Regular inspection and maintenance are essential to ensure the continued reliability of the connection. This includes checking for loose connections, corrosion, and damage to the lug or conductors. If any issues are found, they must be addressed promptly to prevent potential hazards. The consequences of non-compliance with the NEC can be severe. Faulty connections can lead to overheating, arcing, and even electrical fires. These can cause property damage, injuries, and even fatalities. In addition, non-compliance can result in fines, legal action, and loss of insurance coverage. Therefore, it is essential to ensure that all electrical installations are performed in accordance with the NEC and other applicable codes and standards. In summary, while the NEC allows for the termination of two conductors under a single compression lug under specific conditions, it is essential to carefully consider all applicable requirements and ensure that the installation is performed correctly. This includes verifying that the lug is identified for the purpose, rated for the ampacity of the largest conductor, properly sized, and installed using the correct techniques and tools. Additionally, regular inspection and maintenance are essential to ensure the continued reliability and safety of the connection. The NEC guidelines underscore the importance of safety and reliability in electrical installations. It is a code that prioritizes the prevention of electrical hazards and the protection of people and property. Therefore, compliance with the NEC is not just a matter of adhering to legal requirements, but also a commitment to ensuring the safety and well-being of all those who may come into contact with the electrical system. The requirements for terminating multiple conductors under a single lug highlight the need for careful planning, proper selection of materials, and skilled workmanship. It is a reminder that electrical work should only be performed by qualified individuals who have the knowledge, skills, and experience necessary to ensure a safe and reliable installation. For instance, an electrical inspector can offer expertise that helps ensure electrical work adheres to the NEC guidelines. An electrical inspector is responsible for inspecting electrical installations to ensure that they comply with the NEC and other applicable codes and standards. They have the authority to approve or reject electrical work based on their inspection. This means that if an electrical inspector finds that an installation does not meet the requirements of the NEC, they can require that it be corrected before it is put into service. Electrical inspections are typically required for new construction, renovations, and other electrical work. The frequency of inspections may vary depending on the jurisdiction. However, it is always a good idea to have an electrical inspection performed whenever electrical work is done to ensure that it is safe and compliant. In addition to performing inspections, electrical inspectors also provide guidance and education to electricians and other electrical professionals. They can help to clarify the requirements of the NEC and provide advice on how to perform electrical work safely and effectively. Electrical inspectors are a valuable resource for anyone involved in electrical work. Their expertise can help to ensure that electrical installations are safe, reliable, and compliant with all applicable codes and standards. Electrical safety is a critical concern for any electrical installation. Electricity, while essential to modern life, can be dangerous if not handled properly. Electrical hazards can cause serious injuries, including burns, electric shock, and even death. They can also cause fires and other property damage. Therefore, it is essential to take precautions to prevent electrical hazards. One of the most important ways to prevent electrical hazards is to ensure that all electrical work is performed by qualified individuals who have the knowledge, skills, and experience necessary to do the job safely and effectively. This includes electricians, electrical engineers, and other electrical professionals. These individuals should be trained in the safe handling of electricity and should be familiar with the NEC and other applicable codes and standards. Another important way to prevent electrical hazards is to use the right tools and equipment. This includes using tools that are properly insulated and in good working order. It also includes using equipment that is designed for the specific task at hand. For example, when working on live electrical circuits, it is essential to use insulated tools and wear appropriate personal protective equipment, such as gloves and eye protection. Regular inspection and maintenance of electrical systems are also essential for preventing electrical hazards. This includes checking for loose connections, frayed wires, and other signs of damage. Any problems should be corrected promptly to prevent potential hazards. It is also important to keep electrical equipment clean and dry. Dust and moisture can accumulate on electrical equipment and create a fire hazard. Finally, it is important to educate yourself and others about electrical safety. This includes learning about the potential hazards of electricity and how to prevent them. It also includes teaching children about electrical safety and ensuring that they understand the importance of staying away from electrical equipment. By taking these precautions, you can help to prevent electrical hazards and ensure the safety of yourself and others. In the context of terminating two conductors under a single lug, it is essential to consider the potential for increased heat generation. When two conductors are connected to a single lug, the current flowing through the lug is the sum of the currents flowing through each conductor. This can lead to increased heat generation in the lug, which can potentially damage the lug or the conductors. Therefore, it is essential to ensure that the lug is rated for the combined ampacity of the conductors and that the connection is properly made to minimize heat generation. This includes ensuring that the conductors are properly stripped and twisted together before being inserted into the lug, and that the lug is properly crimped using the appropriate tool. Another consideration is the potential for increased voltage drop. When two conductors are connected to a single lug, the voltage drop across the connection is increased. This can affect the performance of the electrical system, particularly for long runs of wire or for circuits that are heavily loaded. Therefore, it is essential to consider the voltage drop when terminating two conductors under a single lug and to ensure that the conductors are sized appropriately to minimize voltage drop. In addition to the technical considerations, it is also important to consider the practical aspects of terminating two conductors under a single lug. This includes ensuring that there is enough space in the electrical panel or enclosure to accommodate the lug and the conductors. It also includes ensuring that the conductors are properly supported and protected from damage. Finally, it is important to document the installation to ensure that it can be easily inspected and maintained in the future. This includes labeling the lug and the conductors to indicate that they are connected together and providing a diagram of the electrical system. In addition to the specific requirements for terminating two conductors under a single lug, it is also important to be aware of the general requirements for electrical installations. This includes ensuring that all electrical work is performed in accordance with the NEC and other applicable codes and standards. It also includes ensuring that all electrical equipment is properly listed and labeled and that it is installed in accordance with the manufacturer's instructions. Finally, it is important to ensure that all electrical systems are properly grounded to prevent electrical shock hazards. Grounding provides a low impedance path for fault current to flow back to the source, which helps to trip circuit breakers or fuses and energize the circuit. This protects people from electrical shock and prevents damage to equipment. In summary, terminating two conductors under a single lug is a common practice in electrical installations. However, it is important to carefully consider all applicable requirements and ensure that the installation is performed correctly to prevent electrical hazards and ensure the reliability of the electrical system. In the context of electrical engineering and safety, understanding the nuances of the National Electrical Code is crucial. The NEC serves as a comprehensive guide for safe electrical installations, and its provisions are designed to protect people and property from electrical hazards. The specific question about terminating two cables under one compression lug highlights the importance of interpreting and applying the NEC correctly. Section 250.12 C of the NEC addresses conductors of different sizes under one terminal. This section generally prohibits connecting conductors of different sizes within the same terminal or splice unless an identified terminal or splice suitable for the purposes used. The intent of this rule is to ensure that the connection is mechanically and electrically sound and that it can safely carry the intended current. If conductors of different sizes are connected in a way that is not properly designed or tested, it could lead to overheating, arcing, or even failure of the connection. However, Section 110.14 C provides an exception to this rule. This exception allows conductors of different sizes to terminate under a single connector if the device is identified for such use and is rated for the ampacity of the largest conductor connected to it. The key phrase here is identified for such use. This means that the connector, in this case the compression lug, must be specifically designed and tested to accommodate multiple conductors of different sizes. The manufacturer of the lug must provide documentation or markings indicating that it is suitable for this type of application. The rating for the ampacity of the largest conductor is also critical. This ensures that the connector can safely carry the current of the largest conductor without overheating or failing. The ampacity rating of a conductor is the maximum amount of current that it can carry continuously without exceeding its temperature rating. The NEC provides tables that list the ampacity ratings of conductors based on their size, insulation type, and installation conditions. When terminating two conductors under a single lug, it is important to ensure that the lug is rated for the ampacity of the largest conductor and that the conductors are sized appropriately to carry the intended current. In the specific scenario mentioned, the question involves terminating two 500 MCM cables under a 1000 MCM rated compression lug. MCM stands for 1000 circular mils, which is a unit of measurement for the cross-sectional area of a conductor. A 500 MCM cable has a cross-sectional area of 500,000 circular mils, while a 1000 MCM cable has a cross-sectional area of 1 million circular mils. If the 1000 MCM compression lug is identified for use with multiple conductors and is rated for the ampacity of a 1000 MCM conductor, it may be permissible to terminate two 500 MCM cables under that lug. However, it is important to verify that the lug is specifically designed and tested for this type of application and that the conductors are properly sized to carry the intended current. In addition to the NEC requirements, it is also important to follow the manufacturer's instructions for installing the compression lug. This includes using the correct crimping tool and die and ensuring that the connection is properly made. A properly made connection is essential for ensuring that the lug can safely carry the intended current and that the connection is mechanically sound. Improperly made connections can lead to overheating, arcing, or even failure of the connection. Furthermore, there are other factors to consider when terminating two conductors under a single lug. These include the type of conductor material, the environmental conditions, and the potential for corrosion. Different conductor materials, such as copper and aluminum, require different types of lugs. Copper lugs are typically used for copper conductors, while aluminum lugs are typically used for aluminum conductors. It is important to use the correct type of lug for the conductor material to prevent corrosion and ensure a reliable connection. Environmental conditions can also affect the performance of the connection. For example, in corrosive environments, it may be necessary to use corrosion-resistant lugs or to protect the connection with a sealant or coating. The potential for corrosion is also a concern when dissimilar metals are used in the connection. For example, if a copper conductor is connected to an aluminum lug, galvanic corrosion can occur. Galvanic corrosion is an electrochemical process that can cause the aluminum to corrode and weaken the connection. To prevent galvanic corrosion, it is important to use compatible materials or to isolate the dissimilar metals with a barrier. In addition to the technical considerations, it is also important to consider the practical aspects of terminating two conductors under a single lug. This includes ensuring that there is enough space in the electrical pile or enclosure to accommodate the lug and the conductors. It also includes ensuring that the conductors are properly supported and protected from damage. Finally, it is important to document the installation to ensure that it can be easily inspected and maintained in the future. This includes labeling the lug and the conductors to indicate that they are connected together and providing a diagram of the electrical system. In the context of electrical safety and code compliance, the installation and termination of conductors are governed by stringent standards outlined in the NEC. The NEC provides detailed requirements for conductor sizing, insulation, protection, and termination methods. These requirements are designed to ensure that electrical systems are safe, reliable, and function as intended. One of the key principles of electrical safety is to ensure that conductors are properly sized to carry the intended current. The NEC provides tables that list the ampacity ratings of conductors based on their size, insulation type, and installation conditions. The ampacity rating of a conductor is the maximum amount of current that it can carry continuously without exceeding its temperature rating. When selecting conductors for an electrical installation, it is important to ensure that the conductors are sized to carry the load current plus any applicable dirting factors. Dirting factors are used to account for factors that can reduce the ampacity of a conductor, such as ambient temperature, grouping of conductors, and conduit fill. In addition to conductor sizing, the NEC also provides requirements for conductor insulation. Conductor insulation is designed to protect the conductor from physical damage and to prevent electrical shock hazards. The NEC specifies the types of insulation that are permitted for different applications and provides requirements for insulation thickness and voltage rating. When selecting conductors for an electrical installation, it is important to ensure that the conductors have the appropriate insulation for the application. In addition to insulation, the NEC also provides requirements for conductor protection. Conductors must be protected from physical damage such as abrasion, impact, and exposure to moisture or chemicals. The NEC specifies the types of protection that are permitted for different applications such as conduit, cable trays, and raceways. When installing conductors, it is important to ensure that they are properly protected from physical damage. The NEC also provides detailed requirements for conductor termination method. The termination method must be suitable for the type of conductor, the size of the conductor, and the application. The NEC specifies the types of terminations that are permitted for different applications, such as lugs, connectors, and splices. When terminating conductors, it is important to ensure that the termination is properly made and that it is mechanically and electrically sound. The use of compression lugs for terminating conductors is a common practice in electrical installations. Compression lugs are designed to provide a secure and reliable connection between a conductor and a terminal. Compression lugs are typically made of copper or aluminum and are available in a variety of sizes and configurations. When using compression lugs, it is important to select the correct lug for the type and size of the conductor. It is also important to use the correct crimping tool and die to ensure that the connection is properly made. Improperly crimped compression lugs can lead to overheating, arcing, or even failure of the connection.